Saucier, this is a video lesson for pre-algebra, contextual problems. Many people call these word problems. But what's important about these problems is not that there are words to express the problem, but that these problems have a context. What do I mean by that? I have two examples here, two of essentially the same problem. They both have lots of words to express them. We could call both of these word problems, but only one of these has a context which makes it a little bit different, and the solution process a little more challenging. The first one reads, if you start at 3, how much do you have to add to get to 12? That's a straightforward math problem. It's abstract. There are words to express the problem, and we might struggle with interpreting those words into an equation or arithmetic problem to solve it. But there's no context. So what do we mean by context? Context is a real world or real world-like situation or activity that contributes to understanding the problem. Contextual problems are good to practice, but they're also the kinds of problems that we might encounter in real life. Situations in which we would want to be able to use math in order to figure something out, improve our understanding. The second one is a contextual problem. Dojo and his friend ate 3 bowls of cereal. They wanted to finish the box, which holds 12 bowls, so they could open their favorite box next. How many bowls do they need to eat? This is a contextual problem because it involves a real-world situation. There are kids, presumably, they're eating cereal, there's a certain amount that has been consumed, there's still bowls left in the box, and we have to figure out how much is left. We have strategies to help us with contextual problems. And we may not use every strategy, but very often when reading a problem like this, there's a lot to read, and understanding what's important and what information we need that will lead to an answer can be challenging. So we offer strategies in order to begin and persevere. The most fundamental of the strategies is to reread. And we could also reread one part at a time. In other words, slow down. Read the problem once, and then go back to the beginning and read it more slowly, one part at a time, one sentence at a time, or one idea at a time. Next strategy is very common, is to visualize. Visualize the situation. If these are going to be real-world problems or something that is like a real-world situation, then it's very often easy to at least begin visualizing what's happening. If we have Dojo and his friend eating bowls of cereal, in our mind's eye, we can picture kids sitting down to breakfast and eating cereal, and then maybe counting how many bowls they eat. Another strategy is describe the situation in your own words. This is a good thing to do in understanding anything. The words that the problem uses may not be the way that you visualize the situation. So to understand the situation, you can interpret and then say it out loud or to somebody else or in your mind. Try to reiterate the words, I mean say it again, but say it in your own way. Like there are 2 kids and they are sitting at a breakfast table. There is cereal on the breakfast table, and they begin to eat. And they eat 3 bowls amongst themselves and wonder how many more bowls do they need to eat in order to finish off the box. Now, that's not exactly what it says in the words, but it gets across the same situation, and it helps me to understand what's going on. Next is draw or diagram. And this could be anything. It doesn't have to be correct. A drawing is a way to begin to understand what's going on. For example, we could think of 2 kids, simple stick figures, and circles to represent the bowls of cereal that they eat. We could imagine a box that we're told about that has 12 bowls inside. And if we're wondering how many remain in the box, we could cross out the circles or the bowls that we're already eating. In this drawing, we're ready to grab it and answer. If there are 12 bowls in the boxes and I already crossed out the 3 that they ate, then there's going to be 9 left. Drawing and diagramming, and identify numbers and units. The units in this problem are 3 and 12. They represent bowls, so bowls would be the units of this problem. And we can identify variables or numbers that change. This problem doesn't have variables in it, or at least it's not required in understanding this situation to think of any numbers that may change. When we get into algebraic contextual problems, identifying variables would be very important. Next strategy, and this is a difficult one, but worth practicing, is guess at equations and then reflect on if they make sense. Equations would be the relationships between the numbers in the problem and the situation, and then reflecting on the equation that you may come up with or guess at to see if it makes sense is a process of guess and check. What's really important in a process of guessing and checking, and why we say guess, is because we want, when thinking about these, the freedom to be wrong, to make choices and experiments and see if it works, to be playful with it. If, when approaching these problems, all we're willing to do or write down is what must absolutely be correct in the end, we might be stunned. We might not be able to do anything if we're worried about only doing things that are correct. So in this situation, an equation I could come up with would be to use the number 3 and the number 12 to represent the 3 bowls that were eaten and the 12 bowls that are part of the box. And somehow we have to eat more. I have to add a certain number of bowls that I don't know yet, so that the total between the 3 that were eaten and the number that we have to eat will be equal to 12. I've created an equation here, and I'm making sense as I write it down. I could think of it again. 3 bowls that were eaten plus the bowls that we have to eat is going to equal the total of 12 in the box. So we have to figure out B. And lastly, the last strategy that we're going to write down is to reread or identify the question. It's worth putting this down as a strategy because very often we can get into an involved problem and do a whole lot of stuff correctly or produce knowledge and relationships and drawings, but we may lose sight of what we're supposed to get at. So it's worth at the end to reread the question. How many bowls do they need to eat? We might have answered it along the way, but if we haven't, let's make sure that we did. This number B must be equal to 9, because only 3 plus 9 will equal 12. 9 bowls.